Okay, let's take a look at the concepts of factoring.
And what factoring is basically you want to express an expression. You want to rewrite an expression in in terms of a product. So, for example, if I say something like factor, factor the number 10, for example, factor number 10, then all you do is express 10 as a product. So you would express 10, for example, as 2 times 5, and that will be the factor for 10. That will be factoring the number 10. All right, so that's what we're trying to do. If I give you a polynomial expression, can we express it as a product? All right, so let's look at that. The first concept we want to get at, though, is the greatest common factor. So let's look at the greatest common factor, or GCF. All right, the greatest common factor, again, that stands for, the GCF stands for that. Greatest common factor. This is the highest factor of, this is the highest number, excuse me, that will evenly divide the number that you're given. For example, if I say, let's find the GCF. Let's find the GCF of, say, 12 and 18. All right, 12 and 18. Now, what does that mean? That means I want you to find the highest number that will evenly divide 12 and 18. That evenly divide means what? That means that when you divide it by that factor, then there's not going to be any remainder here. Okay? So what is the highest number that will evenly divide 12 and 18? Well, if you think about the times table a little bit, you're going to see the answer is going to be what? It's going to be 6. Right? Now, one way to figure it out, though, is to list the factors of 12. 1 is always a factor of the number. All right. 2 is a factor of 12 because 2 times 6 is 12. All right. 3 is a factor. 4 is a factor because 4 times 3 is 12. Right. And then 6 is a factor of 12. And then 12 is a factor of itself. All right. Let's look at 18. What are factors of 18? Well, 1, 2, 3 again. All right. Now 4 is not a factor of 18 because 4 cannot go into 18. All right. 6 can, however, right? What else? 9. And then finally what? 18. So as you can see, now let's look at the common factors. Well, first of all, to be the greatest common factor, you first have to be a common factor. So 2 is a common factor, as you can see right here. So is 3. 3 is a common factor of both 12 and 18. What else? And so is 6. But as you can see, the number 6 is the greatest common factor. That's the highest number that will evenly divide 12 and 18. All right, can we see that? Let's try another one. Let's look at the GCF. Let's look at the GCF, for example, of let's make it 30, 32, and say 48. Okay, 32 and 48. All right. What is the highest number that will evenly divide 32 and 48? Okay, so you have to think about this a little bit now. Okay, you may use your calculator to help you out. All right. For example, you may say, okay, well, let's see. 32, 4 can go to 32. 4 goes into 32 8 times, into 48, what? 12 times, okay? But we can do better than that. How about 8? 8 can go into 32, right? 8 into 32, what? 4 times. 8 into 48, what? 6 times. So 8 is higher than 4. So far, so good. But, however, there's also a number even better than that. So if you think about it a little bit, then you see that 16 works out, because 32 is what? 16 times 2. All right, and 48 is going to be what? 16 times 3. All right, so therefore, the greatest common factor here of 32 and 18, that's the highest number that will evenly divide 32 and 18, is going to be what? It's going to be 16. Okay, so really nothing new here. We've done this before. Now, there is a technique that we used in Math 30 to figure this out, instead of listing these factors, which can be challenging because we may miss a number here, for example, as these numbers get big. But I can show you this technique in class, for example. Okay, so since this is review from Math 30 here, okay? Let's look at the GCF. How about the GCF? GCF of 13 and 19. Okay. Well, the only factors of 13 and 19 are what? Is the only thing they have in common is what? Well, it's going to be 1, right? So can we see that? 1 and 13 here, so that's a prime number, right? 19 is also a prime number. That means what? Prime number means what? It means that the only factors of it are 1 and itself. All right, so 1 and 19, so the only common one is what? 1. So in this case, the answer is 1 here. Okay, so again, can be comfortable finding the GCF of numbers here, right? Let's extend our concept of, let's extend it into what? Exponential expression. Let me go and clear this out. Let's look at the GCF, for example, of x cubed, and x to the 5th power, all right? What is the, so you want to think, okay, now, what is the highest exponential expression that will divide x cubed and also divide x to the 5th, all right? Is the answer x? Well, x will divide x cubed, because x into x cubed, how many times? X squared. X into x to the 5th, how many times? X to the 4th, right? So x is a common factor, certainly, but we can do better than x, right? How about x squared? What is the highest power term that will divide both of these? How about x squared? We may think, well, x squared wouldn't go to 3 and 5, would it? Well, you sure it would, because x squared times what will give you x cubed? Well, x squared times what? Times x will give me x cubed. So x squared is a factor of x cubed. Well, x squared times what is going to be x to the 5th? Well, x squared times what? X to the 3rd is x to the 5th. So x squared also works. But the highest common factor, the greatest common factor of x cubed and x to the 5th will be x cubed. It will be x cubed. All right. Now, you may wonder, okay, why is that? Why is that the answer? Why is it x cubed? Well, so let's look at it then. X cubed, will that divide itself? Yeah, it will. If I take x cubed divided by itself, I get 1, so it evenly divides. All right. How about x to the 5th divided by x cubed? Will x cubed evenly divide x to the 5th? Yeah, it will. It'll be what? X to the what? X to the 4th. Oops. Sorry about that. X squared, I meant to say. My apologies there. Right? So x cubed evenly divides itself. X cubed evenly divides x to the 5th. We get x squared. So sorry about that. All right. Now, how about x to the 4th, you wonder? Well, x to the 4th will not divide x cubed. If I have x cubed here and x to the 4th down here, then it's not going to divide evenly. Okay? So again, we want to find the highest power term that will evenly divide x cubed and x to the 5th, and that answer is x cubed. Okay, let's look at another one. How about the GCF of x to the 9th and x to the 5th, for example. Okay. So what is the highest power term that will evenly divide x to the 9th and x to the 5th? Well, again, if you think about the exponents, because the reason is when we divide exponents, what do? We subtract, right? We subtract the exponents. That's why, in this case, then x to the 5th is going to be the answer. Okay, and why is that so again? Well, let's look at that. X to the 5th, will that evenly divide itself? Of course it evenly divides itself. But how about x to the 9th? Will x to the 5th evenly divide that? Yes, it will, because again, when we divide, we're going to subtract the exponents. That's why this is going to work out to x to the 4th. All right. So again, x to the 5th here is the greatest common factor. All right. Now, from these two examples, we can sort of come to a generalization, right? For exponential expressions here, all right, what is the greatest common factor? Well, it's the expression with what? With the lowest power. That's the greatest common factor. So the greatest common factor of two exponential expressions is the one with the lowest exponent. Can we see that? Lowest power wins, right? X to the 9th, x to the 5th. So what's the GCF? X to the 5th. Lowest power wins. So let me say that exponential expression, all right, with the lowest power, or lowest exponent, I should say, right, is the GCF. Okay, so let's try this one then. Let's try this one down here. Let me give you a pump. How about the GCF then of x to the 4th, y to the 7th, and x squared, y to the 9th? Okay, so it's a 9 there. Okay, so what is the greatest common factor of x to the 4th, y to the 7th, and x squared, y to the 9th? Well, again, lowest power wins, right? Just compare the powers. Well, look, x to the 4th, x squared, lowest power wins. So x squared is the GCF there. Okay. How about the y? Y to the 7th, y to the 9th. Well, lowest power wins, right? Lowest power is the GCF. So y to the 7th. Here's the GCF. So therefore, the GCF of these two expressions is what? X squared y to the 7th. Okay, can we see that? Again, the expression, the exponential expression with the lowest power, lowest exponent, is the GCF. Okay, so keep that in mind here. Let's go ahead and mix in the numbers, if you will. Let's go and try some of these problems. Let's find the GCF. Let's find the GCF of the following. Okay, let's find the GCF of 4 x to the 6, y, and 18 x squared y to the 6. Okay, how about that one? All right, well, yeah. First, let's handle the numbers. Let's handle the numbers first, all right? What is the GCF of 4 and 18? What is the highest number that will divide 4 and 18? Well, the answer is going to be 2, all right? 2 is the highest number that will divide 4 and 18. How about x to the 6, x squared? Well, again, lowest power wins, right? So x squared is the GCF here, all right? How about y and y to the 6? Again, lowest power wins. What's the power of y here? Well, it's invisible 1, right? So y. So therefore, the GCF of these two expressions is what? 2x squared y. All right? Not too bad at all. Let's try one more here. Let's look at the GCF of 4a squared b cubed. All right? 8a cubed and 12ab to the 4th. Okay, what is the GCF of these three expressions now? Okay? Well, again, let's figure out the numbers first. Right? 4, 8, and 12. Hopefully you see the answer is going to be 4 for the numbers. All right? 4 is the highest number that will divide itself, and 8, and 12. All right? How about a squared, a cubed, a? Well, what? Lowest power wins, right? Which one has lowest power? 2, 3, or 1? Well, 1 does, right? So therefore, 4a. All right? Now, how about the b's? B cubed, no b at all, and b to the 4th. Well, since there's no b at all in this second term here, 8a cubed, there's no b at all. That means what? That means b is not even a common factor, right? To be the greatest common factor, you first have to be a common factor. And b is not even a factor of 8a cubed since there's no b at all. So therefore, we don't even consider the b. Can we see that? We don't even consider it because b is not even a common factor here, right? We only consider the common factors. They have a's in common, and the lowest power wins. So therefore, a is all I need here, right? And the GCF of these three expressions then is going to be what? It's going to be 4a. Okay? So it does take a little practice, but once you get used to it, it does happen quite quickly. All right? Now, let's go and look at factoring then. So when it comes to factoring a polynomial, the very first thing we do is what? We write it as the product of the GCF times something. All right? So we notice we take out the greatest common factor first. Let me give you an example of that. Okay? Suppose I want to factor the following expression. Oops. Let's go and factor something like 14. Let's factor 14a squared minus 21a to the 4th b. All right. Let's say I want to factor that binomial here. Right. Two terms. Right. Okay. First thing I'm going to do then is I'm going to look for the GCF. All right. So let's write down the GCF on the side here. Okay. What is the greatest common factor of 14a squared and 21a to the 4th b? Well, let's handle the numbers first. All right. 14 and 21, what's that going to be? Well, that's going to be 7. I hope we can see that, right? So 7 is the greatest common factor of 14 and 21, all right? How about a squared and a to the 4th? Well, lowest power wins. So a squared is the GCF. And again, I don't consider b at all because there's no b here, right? B is not even a common factor. So the GCF here is 7a squared. So the way we're going to factor that is we're going to write this polynomial expression as 7a squared, the GCF, times something, all right, times something. In other words, 7a squared times this expression here will give me back the original, all right? So let's figure out what this something is, all right? So we have to ask ourselves, we figured out term by term, only 2 terms here, right? So we ask ourselves, 7a squared times what will give me back the first term? Well, 7 times 2 will give me 14 back, so it's going to be 2, all right? And how about a squared? Well, look, I have a squared already, so I'm good. 7a squared times 2 will give me back 14a squared. So 2 is all I need, all right? How about 21a to the 4th b? 7a squared times what will give me 21a to the 4th b? Well, 7 times 3 will give me 21, so minus 3, all right? And what else? Well, I have a squared. What else how many more a's do I need? Well, I want a to the 4th, right? So I need 2 more a's. So 3a squared. I also need what? I also need the b, as you can see here. All right. So again, we figured out term by term. We figure out the GCF, 7a squared. Then we write this expression as 7a squared times something. All right. Then we figure out what that something is on a term by term basis. 7a squared times what will give me 14a squared? 7a squared times 2. 7a squared times what will give me 21a to the 4th b? 7a squared times 3a squared b will give me that. All right. Now, suppose you still have a hard time figuring this out in your head. Then you can still do it by hand, but it'll take a little more work. What I mean by that is, how can I do this by hand? How can I figure out this something on paper here? Well, then what you want to do is, once you figure out the GCF, you simply take each of these individual terms and you divide them by the GCF to figure this. See, I want to figure out 7a squared GCF times what, right, will give me back the original. So to figure it out, then you need to take the original divided by the GCF. So, for example, to figure out the first part here, right, let me take 14a squared divided by the GCF, 7a squared. Well, 7 into 14, 2 times. A squares cancel out. The answer is 2. So that's why we have 2 right here. Okay. Likewise, if I take 21a to the 4th b over 7a squared, 7 into 21, 3 times. A squared can cancel with a to the 4th. There's a squared left up here, and there's b left. So therefore, this is going to be 3a squared b. 3a squared b. And that's how we got that. But hopefully we can figure it out in our head without showing all the work here. Okay? But again, this is the solution we're looking for. So I'm factoring means what? Rewriting this expression as a product. And I did that here. Okay? Let's try another one. Let me go and clear off the screen here. Okay? It does take some practice, but once you get used to it, it does happen very quickly here. Okay? Let's try this one here. Let's look at 12m squared plus 6m. All right, plus 6m minus 18. All right, minus 18. So let's go ahead and figure out the GCF right here first. All right, so what's the GCF of 12, 6, and 18? Or 12m squared, 6m, and then negative 18. Okay, just treat it as 18. So the GCF here, as you can see, is just what? It's just going to be 6. All right, it's just going to be 6. Because I don't have an m here, so therefore I can't take out an m, for example. Right? There's no m right here. So just 6. The only number here we have is 6 as the GCF. 6 goes into 12, goes into 6, goes into 18. All right. So let's write this expression then as 6 times something. All right. 6 times what will give me back 12m squared? Well, hopefully you see it's 2m squared. All right. 6 times what will give me back? 6m. Well, 6 times m. All right, 6 plus m. 6 plus m. All right? And 6 times what will give me back 18? Well, 3. So minus 3. All right, again, 6 times 2m squared, 12m squared. Check. 6 times m, 6m. Check. 6 times 3, 18. Check. All right, so this is the solution we're looking for. Yeah, writing as a product. Okay? Not too bad at all. Let's do one more here. All right, how about 20 x to the 4th y cubed. Let's factor this one here. Minus 30 x to the 3rd y to the 4th and plus 40 x squared y to the 5th. And let's factor this expression. A little more challenging here, right? But again, let's find the GCF here. The key is to find the GCF. Once we get that, everything else should fall into place. So let's start with the numbers. 20, 30, and 40. Hopefully you see the GCF is going to be what? 10, because 10 goes in all 3 of these, and 10 is the highest factor that goes into 20, 30, and 40. All right? Not too bad. All right? How about the x's? Well, x to the 4th, x cubed, x squared. Again, lowest power wins, right? Lowest exponent wins. So therefore, x squared is the GCF here, right? So lowest power wins. Okay, lowest power is the GCF. All right. How about the y's? y cubed, y to the fourth, y to the fifth. Again, lowest power wins. Y to the y to the third. Okay, again, 3, 4, and 5. Lowest exponent is the GCF. So y cubed. It's a 3 there. Sorry about that. All right. So that's the GCF. So let's write this product then as what? As 10x squared y cubed. All right. Our GCF times something. Let's make it big here. All right. All right. 10x squared y cubed times what? Let's go turn by turn. 10x cubed, 10x squared y cubed times what gives me back the first term? Well, 10 times 2 will be 20, right? I have x squared. I need x to the 4th, so I need what? I need one more. I need what? One more x or two more x? Well, I need two more x's. Can we see that? And that's it, right? Because I have y cubed is already covered, right? Y cubed, I have that already. So 2x squared is what I need. All right. How about the 30x to the third y to the 4th, second term? Well, that's going to be minus 3 because 10 times 3 will be 30. All right. X squared and x cubed. I need one more x. All right. How about y cubed and y to the 4th? I need one more y. Can we see that? Hopefully you're getting the idea here as I'm working out this example for you. All right. 10 into what? 40 how many times? Well, 4 times, right? So plus 4, all right. And x squared, so I'm good. I'm good on that, right? I have the x squared already, so I'm good on that. Okay, so I have x squared already, so I'm good on that. How about y to the 5th? Well, I have y cubed, so I need what? I need two more y's. So y squared. Okay, so that's the product that we're looking for here. So I factor that expression into a product. Okay, so this is the answer we're looking for. Okay, so again, practice getting the GCF here of the terms, and then practice what? Writing it as a product of the GCF and that. All right, all right. Let's go ahead and extend this GCF concept a little bit here. Let's try this problem. I'm going to put out the screen here. Consider this factoring problem. Let's factor the following. Let's factor x times 3x minus 2 plus 5 times 3x minus 2. Here's one we haven't seen before. Let's go and look at factoring this. Notice, write this as a product. All right. This is currently not a product because yes, I have multiplication here, but I have what? I have addition right here. So it's not a complete product yet. All right. How do I write as a product? Now, before you multiply the x out and multiply the 5 out, I don't want you to do that. All right. I want you to observe two quantities here. Here's the first quantity. Here's the second quantity. All right. Look at this expression as two terms. Here's the first term. Here's the second term. Our first expression, second expression. All right. So look at these two expressions. What do they have in common? Can we see that they have 3x minus 2 in common? Can we see that? All right. So therefore, the GCF of these two expressions now will be what? So the GCF will be what? 3x minus 2. Can we see that? Because both of these expressions have 3x minus 2 in common. All right. Hopefully we can see that. All right then. So since that's the GCF 3x minus 2, then let me take it out. In other words, let me write this entire expression as the product of 3x minus 2, times something. All right, 3x minus 2 times something. Again, because these two expressions have 3x minus 2 in common, I can take it out and then multiply it by something to get back the original. Well, let's go expression by expression. 3x minus 2 times what gives me back the first expression? Well, you can see it's going to be x, right? So I need x right here. Okay. 3x minus 2 times what will give you back the second expression? Well, hopefully we see the number 5. So plus 5. All right. So this is now I have the product. Now it's factored, right? Because this is what one quantity times another quantity. Now it's a complete multiplication problem, which is what I want. Okay, let's try another one. Let's factor this one then. Let's factor 3x times 5x minus y minus 4 times 5x minus y. Okay? So again, let's look at those two expressions here. All right, let's look at these two expressions right here. All right? So again, here's expression 1, here's expression 2. All right? What do they have in common? Well, hopefully we see again right away without too much trouble based on the previous example up here that the GCF is going to be what? 5x minus y. They both have 5x minus y in common. They both have this factor in common. Can we see that? So therefore, this expression can be written as 5x minus y times something. All right? Well, times what will give me back the first expression? Well, times what? 3x. Okay? Times what will give me back the second expression? Well, times a negative 4 or minus 4. Okay? So again, hopefully these problems aren't too difficult for us here. We can see the GCF without too much trouble here. Now let me twist this around on you just a tad here. Let me go clear out the screen. All right. Actually, let me go and do one more before I clear out the screen here. Let's go and do this one here. Let's factor this. 6x times 4x plus 3. Before I give you before I twist the example here, let me do another one for you here. Well, actually, let me scratch this problem. Okay, let's do this. Let me change this problem a little bit. Let's factor this one. Factor 6x times 4x minus 3. All right, and then minus 5 times 4x minus 3. Okay, let's factor that. Okay then, so what's the GCF? Once again, you see 4x minus 3 in common here, right? So the GCF is going to be what? 4x minus 3. Okay, GCF is 4x minus 3. So therefore, this problem factors to what? 4x minus 3 times what? Well, times 6x for the first expression, and times what? Minus 5 for the second expression. Okay, so this is the answer we're looking for. Right here. Okay, so 4x minus 3 times 6x minus 5. So again, no big deal here. They both have 4x minus 3 in common, so therefore I can take it out. And then times what will give me back the first expression? Times 6x. And then times what will give me back the second expression? Times negative 5. All right. Now let me twist this problem around on you just a little bit, though. Let's try this one here. Okay, let's go and factor this one. How about this one? How about 6x times 4x minus 3 still, all right? But except now it's going to be minus 5 times 3 minus 4x, okay? Let me change that around on you just a little bit here, okay? Well, look at this now. 4x minus 3, now here I have what? 3 minus 4x. So my question is, well, these don't look quite the same. Can we see that? Because the order of the subtraction is switched around. Can we see that? All right. So, but they're almost the same, right? It's just the order is switched around on the subtraction here, right? Well, what does it mean when the order of, so 4x, I'm talking about 4x minus 3 here and 3 minus 4x. Since the order of the subtraction is switched around, what does that imply? Well, here, let me do a little problem on the side here. If I have 5 minus 2, we know the answer is 3, right? But if I switch the numbers around, 2 minus 5, what is the answer now? Well, hopefully you see it's negative 3. All right? So what does that mean? That means that if I change the order of the subtraction around, then I get a number, I get an answer that is the opposite of this answer here. In other words, what I'm trying to say here is that 3 minus 4x, because the order is switched around, 3 minus 4x is the opposite of 4x minus 3. In other words, let me do this. Let me write 3 minus 4x right here. Okay? Now, what happens if I take out a negative sign, if you will? If I take out a negative sign, then what happens? Well, this positive 3 becomes what? Negative 3, right? This negative 4x becomes what? Positive 4x. Can we see that? Again, well, you can check it by redistributing it, right? What is the opposite of negative 3? Positive 3. Check. What is the opposite of positive 4x? Negative 4x. Check. All right? But look at negative 3 plus 4x. Let me rewrite that. Let me write the x term first. So that's going to be positive 4x, all right? And then negative 3 minus 3. All right? So what that tells us is what? That 3 minus 4x is the opposite of 4x minus 3. Again, this is telling us opposite of 4x minus 3. Okay, can we see that? All right. So again, if I change, so my point is again, if you change the order of the subtraction around, you get the opposite of the original answer there. All right. So 3 minus 4x, which is switching the order of 4x minus 3, then that means 3 minus 4x is what? The opposite of 4x minus 3. So knowing that, I can replace this 3 minus 4x in this expression here, in this second expression, with the opposite of 4x minus 3. So let me do that. But what's this negative sign? This negative sign is really a negative 1 here, isn't it, right? Invisible 1, right? So let me do this. Let me keep the first expression the same. So 6x times 4x minus 3, all right? Now, and then minus 5, all right? But now, look at 3 minus 4x. I'm going to replace that with what? Negative 1, again, invisible 1 here, negative 1 times 4x minus 3. Because 3 minus 4x is the opposite of 4x minus 3. Okay, again, this negative sign out here is really a negative 1. So minus 5, bring it down. All right, now let me write negative 1 times 4x minus 3. Okay, can we see that? And the reason I want to switch them around by taking out a minus sign, by taking out a negative 1 namely, is because I want the 4x minus 3's to be the same. That way it becomes the greatest common factor here. Can we see that? But look what happens also. If I take out a negative sign, or negative 1 in this case, then what happens to the minus 5? Well, look, minus 5, negative 5, and negative 1, that's positive 5, isn't it? So I get 6x times 4x minus 3 plus, right, negative positive 5 times 4x minus 3. So my point is, when we take out a minus sign here to switch the order around, right, then this sign will change out here from minus in this case to what? To plus. Can we see that? So we don't actually have to show this step right here on the homework. All right. So we just switch the order around and basically change this sign out here. Okay. Can we see that? So now I have a problem that I have up here. Okay. So the GCF here now I can say is 4x minus 3. So therefore the answer is going to be 4x minus 3, factor it out, times what? Times 6x plus 5. Okay, so now this is the solution we're looking for here. Okay, can we see that? So it's a little bit different here with this problem because the order is switched around in terms of subtraction here, right? Then now how about if the order switched around for addition? Well, for example, if I say 5 plus 2 and 2 plus 5, well, they're both the same. So if the order is switched around for addition, then they're not opposites, okay? So be careful here, all right? If the order is switched around for subtraction, yes, they are opposites, all right? So keep that in mind. So this only applies when we have minus here, and the order is what? Switched around, okay? So let's see if we can handle that. Okay, let's try another one. Let's try this one here. Let's go and try this problem right here, all right? So let's look at 2x. Let's look at, 3y, 3y times 5x minus 2. All right, 5x minus 2 plus 4 times 2 minus 5x. Okay, let's try that one here. All right, so what happens now? So now what happens is that the order is switched around. Can we see that for the 5x minus 2 and the 2 minus what? And the 2 minus 5x, right? Hopefully we can see that without too much trouble. Okay, so therefore, I want to switch this around, okay? If I can switch this to 5x minus 2, then I'm good because then I have the GCF as 5x minus 2. Can we see that? And you may wonder, can I switch this around instead of this one? Yeah, you can, but let's go and write the x term first, so I like to switch this around instead, okay? But again, if I do switch this around, I need to put a negative out here, okay? All right, so because, again, to switch it around means what? We're taking out a negative 1. Remember how I did that in the last example? So you might want to replay that example previously, okay? So let's go ahead and do that then. So first one stays the same. All right, so the first expression stays the same. Let me fix my sketch pad a little bit. Sorry about that. Okay, so I get 3. Okay, so I get 3y times 3y times 5x minus 2, that stays the same, all right? And now I'm going to switch this around. And when I switch that around, this plus out here becomes what? Becomes a minus, all right? And now the order is switched around. 5x minus 2. Again, because I'm taking out a negative sign. I'm taking out a negative sign to switch this around like I did earlier. So what I'm saying is 2 minus 5x is equal to the opposite of 5x minus 2, right? Right? If I apply the negative sign here, opposite of 5x, negative 5x, check. Opposite of negative 2, positive 2, check. So therefore, to switch this around, I need to take out a negative sign. And when I do that, then this plus becomes a minus here. So I have this result, right? Again, I took out the negative 1 here. That switches to plus 2 minus. Then because of that, then I have 4 times, and now I can switch the order around here. So therefore, 5x minus 2. So now I have my GCF here as 5x minus 2, if you will. All right, so I have 5x minus 2 there. So therefore, this answer becomes 5x minus 2 times what? 3y minus 4. Okay, can we see that as our solution here? Okay, let's try one more here. All right, let's take a look at this one here. Let's take a look at 4a times 5a minus 7b. Right, minus, let's make it 9b times 7b minus 5a. Okay, let's go and factor that one. Again, notice that 5a minus 7b and 7b minus 5a are switched around, so therefore they are opposites of each other. So therefore, I want to switch this around right here. Okay, so let me keep the first one the same again. So 4a times 5a minus 7b. All right. Now let me switch this order around. And when I do that, though, what happens to this minus up here? Well, it becomes what? It becomes plus. All right. Plus 9b times what? The order gets switched around. 5a minus 7b. Okay. Again, because I'm taking out a negative sign here, then that changes this negative out here to a positive. Okay, because I have two negatives. And if I take out a negative sign from here to switch this around. Okay, so let's go ahead and think about this carefully. All right. So there's my GCF again, right? 5a minus 7b, 5a minus 7b. So therefore, I'm going to have 5a minus 7b as the GCF times something. Times what? 4a plus 9b. 4a plus 9b. Okay, as my solution here. So again, not too bad at all. Be sure we can handle these types of problems here. Okay, let's extend this concept here. Then let's extend this GCF concept into a concept that's going to be important to us in the next couple of sections here, and that's let's look at a factoring technique called factor by grouping. And so let me go and clear out the screen here. Let's look at this concept called factor by grouping. We use this technique when we have to factor a polynomial of 4 terms, typically, right? So let me give you an example of that. Right, consider this problem here. Let's say I want to factor the following polynomial. Let's say I want to factor 8x squared, 8x squared plus 12x, all right, plus 12x plus 6xy plus 9y. All right. Let's say I want to factor this polynomial of 4 terms. Okay. Now, it's a very challenging factoring problem, but if I know this technique, factor by grouping, is actually not too bad. All right. So how does this technique work? Well, here's how it works. Then. Well, you want to break these 4 terms up into 2 groups, of 2 terms. Okay. So let me group 2 terms together. Let me group the first 2 terms together as one group. Let me group the next 2 terms together as a second group. So typically, we'll group the first 2 terms as group 1, next 2 terms as group 2. Okay. Now, what do I do within each of these 2 groups? Well, within each of these 2 groups, I want to take out the GCF. All right. So let's look at the first group. That means ignore these 2. Look at the first group. That means the first 2 terms. The first 2 terms. What is the GCF here? Well, 8 and 12. That's going to be what? 4. All right. X and X. So that'll be what? X. So that's the GCF. So 8x squared and 12x, I can take out 4x. So what's left? Well, I have 2x left plus what? 4x times what will give me 12x? 4x times 3. Can we see that? So again, I group the first 2 terms as one group and the next 2 terms as the other group. And within each group, I'm going to factor out the GCF. So here it's going to be 4x times what? 2x plus 3. Okay? How about over here? Let's look at the second group now. Ignore the first group. Look at the second group. All right? What is the GCF of 6xy and 9y? Well, hopefully we see that. Now put a plus here, okay? We see that's going to be what? Because of this plus right here. All right? And let's take out a positive here. Positive what? Positive 3 here, right? So positive 3 taken out, all right? Positive 3 taken out, what else? Y is in common, right? 3y, okay? So what's left? 3y times what gives me 6xy? 2x, all right? 3y times what gives me 9y? Positive 3, okay? Can we see that? And look, after I break it up into two groups and I take out the GCF, look what I have. I have a problem that I've seen before in the previous examples, right? 2x plus 3 is the GCF of these two expressions. Can we see that? So therefore, the answer is going to be what? 2x plus 3 times what? 4x plus 3y. Okay? So that's our solution. Right? Let's try another one. Let's try another one. Let's look at 7xy squared minus 3y plus 14xy, all right, minus 6. Okay, let's try this one. All right, again, factor by grouping, 4 terms, right? You want to use this technique, factor by grouping. All right, so let's group the first 2 terms as one group, next 2 terms as another group. All right. For the first group, let's take out the GCF. All right, what is that? Well, they only have what? Y in common. Can we see that? So I can only take out a y. So what's left then? 7xy here, because 7 times y times 7xy will give me 7xy squared. Can we see that? And then y times what gives me the minus 3y? So just minus 3. All right. What's in common here? Well, 14 and 6, that's going to be what? 2. I can take out a 2 right here. Okay. Now, make sure you put a plus right here again, right? But don't forget about that, right? Because if the third term in the polynomial is positive, you want to take out a positive number. If the third term is negative, which I'll give you in a second, then we'll take out a negative number, and that's a little more challenging. So we'll look at that next. All right. But again, 14 and 6, 2 is in common. Take it out. All right. Anything else? No, that's all. Right. So 2 times what? 2 times 7xy, all right, because 2 times 7xy is 14xy, and 2 times negative 3 will give me negative 6, all right? And look, again, I have 7xy minus 3 as the GCF here in both of these expressions. So my final answer is going to be 7xy minus 3 times what? Y plus 2. Okay, so it's a very important technique that we learn here, factor by grouping. Okay, so focus on these types of problems here. Okay, so there's my solution: 7xy minus 3 times y plus 2. Okay, let's do some more examples. Let's try this one. Okay, let's take a look at this one here: 5xy minus 9y, all right, minus 18 plus 10x. All right. Let's go ahead and look at this problem here for a second. Okay. All right. Let's first group the first 2 terms together and the next 2 terms together. All right. So factor by grouping. Okay then. So what's the GCF in the first 2 terms? Well, it's just going to be y. Can we see that? Take out a y. So I have 5x minus what? Minus 9. All right. Can we see that? I have 5x minus 9 here. Okay. Good. Now for the next 2 terms, since the third term is I'm thinking about this example. This is probably not the best example to show you here. I'll give you another one in a moment. Okay. But since this third term is negative, let me take out. Again, I mentioned it earlier. If a third term is negative here, take out a negative. All right. So yes, 18 and 10. The GCF is 2, right? But don't take out a plus 2. Let's take out a minus 2. All right. Now, when you take out a minus 2, you have to be a little more careful here. And here's what I mean by that. Because if I take out a negative 2 here, all right, let's ask ourselves, negative 2 times what will give me back the negative 18? Well, it's going to be times what? It's going to be times 9. Okay, so be careful. Don't think it's negative 9, because negative times negative then becomes positive. Then I'm changing the problem, right? So again, if I take out a negative 2 times what will give me back negative 18? Times positive 9. negative 2 times what will give me back positive 10x? Well, as you can see, that's going to be what? Minus 5x, okay? Again, you may be tempted to put plus 5x, but that's wrong because what's negative 2 times plus 5x? That's negative 10x, but I don't have that. I have positive 10x in my original problem. So therefore, negative 2 times negative 5x will give me positive 10x. All right, are we good on that? Well, again, look at this problem here. We've seen this before, right? The 5x minus 9 and 9 minus 5x are opposites, right? These are opposites of each other, are they not? So therefore, I can take out a negative here. So one more step here, right? So for this one stays the same, all right? And I want to switch this order around to make it 5x minus 9, so I need to take out a minus sign. When I do that, this negative here becomes what? Positive 2. Now I can switch the order around, 5x minus 9. So again, replay the other examples previously if you need to for this lecture. All right? So therefore, I have 5x minus 9 in common here, so my solution is 5x minus 9 times what? Y plus 2. Okay, so again, that's our solution, 5x minus 9 times y plus 2 here. Okay, so let's go ahead and do one more here. I want to do another example for you before we finish off, and I'll give you some problems to try on Blackboard here. Okay, so let's go and do one more here, if you will. Okay, let's try this one here. Okay, sorry about the phone interruption there. Let's go ahead and look at one last example here. Let's look at xy minus 6y minus 2x plus 12. Okay, let's take a look at this last example here on factor by grouping. All right, so let's go ahead and group the first two terms together as one group and the next two terms together as another group. All right, so we have what's in common here? Well, just y again, right? So let's take out a y here. So I have x minus 6 left over in the first group. Can we see that? All right. And for the second group, again, if the third term, again, is negative, you want to take out a negative like we did up here. Okay, so let's take out a negative 2 in this case, since that's the GCF here. Take out negative 2 in the second group. So what do I have left? Well, I have x left, and I have, now be careful here, right? Don't put plus 6. It should be what? Minus 6 here, right? Can we see that? Again, check yourselves by multiplying back out. What is negative 2 times x? Negative 2x. Check. What is negative 2 times negative 6? Positive 12. Check. All right? So therefore, my final answer then, look, I have x minus 6 in common here. So therefore, my final answer will be what? X minus 6 times what? Y minus 2 as our solution here. Okay, we see that? So therefore, we need to get familiar with this technique here on factor by grouping. We'll use this technique again in a future section. All right, so keep this technique in mind. We typically use this for what? For 4 terms here, though. All right. Okay, then let me give you some problems to post on the discussion area in Blackboard here. So let me go ahead and give you some problems to try here. All right. Let's go and post the solutions to the following problems here. Okay, so let's go ahead and factor the following problems here. All right, let's factor 15x squared y plus 20xy minus 10xy squared. Okay, let's go and factor this problem here, right? All 3 problems are factoring problems. So write this as a product, that means, all right? First thing we do is we take out the GCF, and you remember that, right? Okay, so number 2, let's go ahead and try this one here. Let's look at x cubed plus 4x squared, all right, plus 3x plus 12. Okay, so 4 terms factored by grouping here. Okay, so make sure we see that. All right, number 3, let's go ahead and look at this one here. Let's look at x squared plus 4x. Okay, plus 4x minus let's make it minus yx minus 4y. Okay, so let's try this one. X squared plus 4x minus yx minus 4y. Okay, so again, x squared plus 4x minus yx minus 4y. Okay, so let's go ahead and post the answers to these 3 questions in the discussion area on Blackboard then. Okay, so until next time. Bye-bye.